Hello students, this is Harish Konda. Welcome to my channel, the Chemistry Class 2. So before starting the class, I want to share one thing. So here we crossed 250. Thanks everybody who cooperated me and who subscribed me. మీ అందరికి నేను చాలా ధన్యవాదాలు తెలియజేస్తా ఉన్నాను. ఎందుకంటే ఈ జర్నీలో మీ అందరి సహకారంతో 250 క్రాస్ అయినాం మనం సబ్స్క్రైబర్స్ని. సో కీప్ ఆన్ వాచింగ్ మై వీడియోస్ అండ్ థ్యాంక్స్ ఫర్ సబ్స్క్రైబింగ్ and forward my videos also. Promote my channel. So because it is very useful to the students, why? Because the chemistry class. The chemistry is the tough and easiest subject and it is very important for IIT. So ప్రతి ఒక్క పిల్లవాళ్ళు కూడా ఎవరైతే నా ఛానల్ని సబ్స్క్రైబ్ చేసుకున్నారో వాళ్ళందరికీ నేను మరొకసారి రిక్వెస్ట్ చేస్తా ఉన్నాను, ప్రమోట్ మై ఛానల్. సో ఎవరైతే ఇప్పుడు నా వీడియో చూస్తున్నారో ప్లీజ్ లైక్, షేర్, కామెంట్ అండ్ సబ్స్క్రైబ్. Don't forget to bell. So already what we discussed, the isomerism we are discussing. So already structural isomerism we discussed. That is under the description. You get that video. And we are continuing that structure, that is isomerism. So the isomerism is completely classified into two. The one is called structural isomerism. The second is called stereoisomerism. So based on the structures what we get, that is structural isomerism. Based on the spatial arrangement towards the atom, central atom, how the remaining atoms are arranged, the spatially how they are arranged. Based on that we are getting one isomerism, that is called stereoisomerism. So how the stereoisomerism occurs? So what are the stereoisomerisms we have? Now one by one we discuss. So the stereoisomerism, it is our topic today. So this stereoisomerism, it is classified into two. The one is called configurational isomerism. The second is called conformational isomerism. The one is configurational isomerism. The second it is called conformational isomerism. The both undercomes stereoisomerism. Why? Because the spatial arrangement, how they are arranged. So based on that only we are discussing about the isomerism. So one is called configurational. The second is called conformational isomerism, that is stereoisomerism. So again this configurational isomerism, again it is classified into two. The one is called geometrical isomerism and second is called optical isomerism. The one is geometrical isomerism, the second it is called optical isomerism. So here the stereoisomerism, the spatial arrangement, based on the spatial arrangement they differ on the spatial arrangement. So that isomers are called stereoisomers. The phenomena is called stereoisomerism. So I am classifying the stereoisomerism into two. The one is configurational, the second it is conformational. So again the configurational isomerism we classified into two. The one is called geometrical isomerism, second it is called optical isomerism. So what are they? One by one we discuss. So very first I am discussing about the geometrical isomerism. What is the stereoisomerism it is? So how it performs? So one by one we discuss. So what is the isomerism? It is geometrical isomerism. So here what we are discussing, it is the first one, geometrical isomerism. So what is geometrical isomerism? How it performs? What is the spatial arrangement in geometrical isomerism? Now we discuss. So before starting the geometrical isomerism, to perform the geometrical isomerism, compulsory one condition is required. So what is that condition? So which compounds, that is having pi bonds, that means unsaturated compounds. Unsaturated compounds will perform the geometrical isomerism at pi bond. It is double bond, should be double bond. At double bond only the geometrical isomerism is performed. That means the carbon should perform, it is double bond. The double bond natured compound only performs the geometrical isomerism. So why they are performed, later we discuss. So one more condition we have. So when the carbon is performed two bonds with another carbon, still the carbon has to form two bonds. This carbon has to form two bonds. The two bonds are not identical. What is the second condition? These two bonds not identical. When it is not identical, then only it performs the geometrical isomerism. For example, here one hydrogen I am substituting, here one group I am substituting, that is CH3. So these two are not identical. One is hydrogen, the second is methyl group. So if these two are identical, that means this is hydrogen. If it is also hydrogen, the compound is not performing the geometrical isomerism. The compulsory these two groups should be differ. Then only it performs the geometrical isomerism. So here also, so what is the condition? One is hydrogen I am substituting, the other the CH3 group, methyl group I am substituting. The compound is called 2-butene compound. What is the compound? It is 2-butene. How it is, you see? 1, 2, 3, 4. The 4 carbons we have. The compound is having one pi bond, so the alkene compound, so it is butene compound. At second and third carbon we have the double bond, so it is called 2-butene compound. So in 2-butene compound, the carbons are participating in double bond and the carbon is having two different groups on carbon. So automatically it performs the geometrical isomerism. It fulfills the conditions. So what is the conditions? The one should be double bond and second, these two groups are not identical, then only it performs the geometrical isomerism. These two conditions are fulfilled by 2-butene. Then only it is performing the geometrical isomerism. So here the spatial arrangement, based on the spatial arrangement, geometrical arrangement, so they differ. The 2-butene compound, so I am writing one more compound, you observe, this compound you observe. So what I am changing here it is, so here what is there, two compounds have the difference here you see. So in the second carbon, the hydrogen at the top position, the CH3 at the bottom position. Here you observe the second carbon, the CH3 group is the top position, the hydrogen at the bottom position. So what they are differing, the geometrical arrangement, the spatial arrangement they differ. This compound also called 2-butene, why? Because 1, 2, 3 and 4. So here we have one double bond, so it is alkene, 4 carbon alkene is butene. At the second carbon only we have the double bond. This compound also 2-butene. But these two compounds are not same. The two compounds are not identical. Why? Because they are differing. How they are differing? Based on the spatial arrangement. Stereoisomerism. So based on the stereo arrangement, spatial arrangement, the two are differed. So why the two are differed? The carbon and carbon is performing the double bond. Because of the double bond, here the rotation is restricted. What it is called? Rotation is restricted. For example, you see these two carbons are performing the double bond. So when the two are in the double bond, so the carbons are not able to rotate. If you want to rotate, so automatically the bonds are going to break. So that's why the two carbons, between the two carbons, the rotation is restricted. That means restricted rotation we have. Because of the restricted rotation, so once these groups are arranged in one side, the second compound we are differed. So why? Because the arrangement is different. So that's why the two compounds are performing geometrical isomerism. I am repeating, you see. To perform the geometrical isomerism, the carbon should be perform the double bond, and at the carbon we have two groups, one group at one side and another group at another side. If they differ in these groups, if the spatial arrangement around this carbon, if they differ, they are called geometrical isomerism. So here you see, in these two compounds, the hydrogens are in the same side. Here the hydrogens are in the opposite side. or the CH3 groups are in the same side. Here the CH3 groups are in the opposite side. How we are arranging the spatially? So the two hydrogens are the same side we are arranged. Here the two hydrogens are oppositely they are arranged. If they are arranged in the same side, this compound is called cis compound. If they are arranged in the opposite side, they are called trans compound. So cis-2-butene, the second one is trans-2-butene. Here you observe the two compounds are 2-butene compounds only. But they are different. This compound and this compound, they differ. How they are differing? Because of the spatial arrangement, they are differing. That's why the two are called the stereoisomers. In the stereoisomers, the geometrically we are differed. So how the geometry you see? The carbon is performing sp2 hybridization. This carbon also sp2. So geometrically what is the shape of this one? It is triangular planar. So it is triangular planar. This corner we have the hydrogen. In this triangular planar, this carbon we have the CH3 group. So geometrically they are differing. These two compounds geometrically they are differing. That's why it is called geometrical isomerism. So second isomerism we discuss, that is called optical isomerism. So what is optical isomerism? How they are performing the optical isomerism? Now we discuss. So what is our second one? It is called optical isomerism. So it is also the spatial arrangement. Because of the spatial arrangement only, they perform the optical isomerism. So how they are performing the optical isomerism? To get optical isomerism, some conditions are required. If we satisfy that conditions, then only it performs the optical isomerism. So what are the conditions now we first observe? So what is the optical isomerism? They differ in the optical rotation. They differ in the optical rotation of the light. So the molecular formula is same. The compound, they are differed in the spatial arrangement. Because of the spatial arrangement, they rotate the rotation of the optical light. They differ in the rotation of the optical light. So they are called optical isomers. The phenomena is called optical isomerism. So before the rotation of optical light we discuss. So very first we introduce. So which carbons are undergoes the optical isomerism? Which carbons are performing the, which compounds are performing the optical isomerism? Now we discuss first. So what is the condition? It is the carbon, it should be asymmetric carbon. That carbon is called chiral carbon. So if you have one chiral carbon in the compound, that compound only performs the optical isomerism. So if you have chiral carbon in the compound, if you have at least one chiral carbon in the compound, that only performs the optical isomerism. So what is the chiral carbon? Here it is, the carbon should be saturated. That means the carbon should perform 4 bonds, the 4 are sigma only, and the 4 with 4 different atoms or 4 different groups. So the carbon is performing with 4 different atoms, or if it is 4 different groups, then only the carbon is called chiral carbon. That carbon only participates in, that carbon only performs optical isomerism. So here you see, for example, the one atom is A, the another atom is B, then it is C, and then it is D. So what happened here? The 4 atoms are different. So when the 4 atoms are different, the carbon is called chiral carbon, like the star we are indicating. So this carbon is chiral carbon. So for example, we observe the one is hydrogen, for example, one is fluorine, the second one is chlorine, and the third one is bromine. So here you observe the 4 atoms are different. When the 4 atoms are different, so automatically this carbon is called asymmetric carbon, chiral carbon. Now it performs optical isomerism. So here, to perform the optical isomerism, what is your condition? The carbon should be chiral. When in the compound at least one carbon is chiral, then only it performs optical isomerism. So here the carbon is chiral. So what is the chiral carbon? If it is attaching with 4 different atoms, that carbon is called chiral carbon. If two are identical, that compound is not performing the optical isomerism. For example, here you see, if instead of hydrogen, instead of fluorine, if you have hydrogen, the two are identical, so it is not chiral carbon, so it is not performing the optical isomerism. The carbon should be chiral, then only it performs the optical isomerism. So here the carbon, when it is attached with four different groups or four different atoms, that carbon is called chiral carbon. One more example we'll see. This carbon, it is attached with hydrogen. This side I am attaching with CH3 group, methyl group. This side I am attaching with ethyl group, C2H5. This side I am attaching with propyl group. So here this carbon, you see, one side you have the hydrogen, the another side you have one group, that is methyl group, one side you have ethyl group, and one side you have propyl group. The four are different groups you have. That's why the carbon is called chiral carbon, asymmetric carbon. Then carbon will perform the optical isomerism. So actually what is the name of this compound? Here 3 and 4, 5, 6. So it is a hexane compound. At third position you have the methyl, so it is 3-methyl-hexane. The compound is 3-methyl-hexane. In 3-methyl-hexane, only one chiral carbon you are identifying. At third position only you are identifying the chiral. So here these two carbons are not chiral. Here three carbons are not chiral. This one carbon also not chiral. Why? Because they are having identical groups. Here the three hydrogens are identical. In these two carbons, the hydrogens are identical. In these three carbons, the hydrogens are identical. But when you observe this carbon, third carbon, so one side you have the hydrogen, the another side you have the CH3 group, and another side you have the ethyl group and propyl group. That's why the carbon is called chiral carbon. It only performs the optical isomerism. One more example we'll see, the carbon. So one side I am writing CH4 group, and another side I am writing OH group. The one side I am writing hydrogen, and one side it is CH2OH. This compound is called glyceraldehyde compound. What is the compound? This glyceraldehyde. The glyceraldehyde carbon, the carbon you observe, this carbon is chiral carbon. Here the first carbon you observe, the first carbon is having double bond O, CHO, so it is double bond O. The carbon is having double bond, so it is not saturated, so that carbon is not chiral. So here you see the two hydrogens are identical, so this carbon also not chiral. But we observe the second carbon, so the carbon is having one side CHO group, another side hydrogen group, one side OH group, and another side CH2OH group. So this carbon is chiral. At least if you have one chiral carbon, then only it performs optical isomerism. So this compound can perform optical isomerism. So when we have the chiral compound, so here chiral carbon, so they are performing two compounds. They are mirror image. One compound to the another compound, they are called mirror images. You write here, see the compound same I am writing. So the two compounds, they are differ in the spatial arrangement. How the spatial arrangement they are differ, you see. The carbon, the OH, when the right side you are attaching, here the compound, the carbon OH, left side you are attaching. So what is the difference here? The spatial arrangement of the groups, they differ. These two compounds are not identical. Why? Because the two are mirror images, just like our hands, the right hand and left hand. Similarly, the mirror images, the two are mirror images. Similarly, these two are mirror images. So in the one compound, the carbon is attached with right side OH. In another compound, the carbon is attached with left side OH. So the spatial arrangement is different. So the two compounds, they spatially they differ. So these two compounds, how they are differing? They are differing in the optical rotation of the light. So optical light, they rotate. So how they are called? Optically they rotate. That light is called polar light. The polar light is rotated in one side. The polar light may be rotated to the right side, or the polar light may be rotated to the left side. The one compound, if you take, the polar light, it rotates to the right side. The another compound, if you take, the polar light, it rotates to the left side. So the two compounds, how they are differing? They are not identical. Why? Because the spatial arrangement is different, and the two compounds, so what they are doing? They are rotating the light opposite way. So one is rotating in the right side and another is rotating in the left side. That's why the two are called optical isomers. They are called enantiomers also. So what they are called? Enantiomers also. So how they are rotating the light? Now we see. So about the polar light once we discuss. So what is the polar light? So when you see the light, so here the light beam is coming. The kite is spreading over towards the all sides. This light is spreading over the all side. So this light is called polar light. When you observe from a circle, the light is completely spread over in the circle. The light is completely spread over in the circle. That light is called polar light. For example, you see one glass tube I am taking here. This glass tube. So from here I am observing this glass tube. So from here I am observing. So from here the sunlight or the source of the light. So I am generating the light. So from this light it is passing from this tube. So from here I am observing. So in this test tube, in the tube, so what I am filling? I am filling with one polar compound. What is the polar compound? It is which is optically active. So it can rotate the polar light. So that's why they are called polar compounds. They are called optical active compounds. So first compound I am filling in this tube. So the first compound I am filled in this cube and I am observing this light. So when I am observing, if it is non-polar, if it is not optically active, so what you observe, the complete light should be spread in the circle. But when it is polar, when it is optically active, the compound, what is filled in the tube, it is optically active. So what happened here? If it is this compound, if it rotates the light towards the right side, so what happened here? The circle forms like this. So it is the circle. The total light is spreading only towards the right side. The opposite side, what you are getting, it is completely dark only. The dark completely, what you are observing, the dark. Why? Because the complete light rotates towards the right side. So other side, what you are observing, it is completely dark only. The one side only you are observing the rays. So that means the polar light, it is rotated towards one side. So which side it is rotated? The right side it is rotated. When the compound, what you are observed in the tube, so it is rotates towards the right side. That compound is called dextro compound. What is the compound? It is dextro compound. So if you fill with the other compound, another compound if you fill, so what is the compound? It is a mirror image of this compound. That compound I am filling in the tube. So it is having the opposite property. It rotates to the left side. So what you observe, the polar light. So if it is rotated towards the left side. So when it is rotating to the left side, the opposite side it is completely dark only. So why? Because the second compound, it is completely rotating the light towards the left side. It is optically active compound. It is oppositely it is rotating. In the left side it is rotating. So this compound is called Leo compound. You observe these two, the two compounds I am observing. These two compounds are mirror images. So they are not identical. Why? Because the two are not overlapping one side. So for example, you observe these two hands. The one is right hand and the second is left hand. So when you overlap these two, they are not going to overlap each other. So similarly, these two compounds are not overlapping. The OH on hydrogen, the OH on hydrogen. So it is not going to overlap. So the two compounds are differ. So one compound is optically, what it is rotating, the light it is rotating towards the right side, and another compound is rotating towards the left side. So what happened? That they differ. How they are differing? They are differed in the optical rotation. How they are differed? They differed in the optical rotation. Because of the spatial arrangement, they are differing in the optical rotation. That's why they are called optically active compounds. This phenomenon is optical isomerism. One compound is rotating towards the right side and another compound rotating towards the left side. If it is rotates towards the right side, that compound is called dextro compound. If it rotates towards the left side, that compound is called Leo compound. So this phenomena is called optical isomerism. The polar light. So what they are differing? They are having the same formula, but they are having the same molecular formula, but because of the spatial arrangement, they are differing in polar light rotation. One is rotating towards the left side, one is rotating towards the right side. So they are differed in the optical rotation. That's why they are called optical isomers. The phenomena is called optical isomerism. So it is also one stereo isomerism. These two are called configurational isomerisms. So one is geometrical isomerism, the second is optical isomerism. They differ in the spatial arrangement. So one should be double bond and here the carbon should be chiral. Then only it performs the geometrical and here it is optical isomerism. So here the students, so please go through my videos, then only you can follow the remaining next, the confirmations we discuss in the next video. And before closing the video, so I am requesting you all, please like, share, comment and subscribe. Don't forget to bell and promote my channel. Why? Because it is very useful to the required students. So when you promote, it is very useful to the other needed students also. సో కాబట్టి అందరు కూడా ప్లీజ్ నా ఛానల్ని ప్రమోట్ చేయండి. కెమిస్ట్రీ ఎందరికీ ఉపయోగపడుతూ ఉంటుంది ఐఐటి స్టూడెంట్స్కి. సో వాళ్ళందరికీ మీరు కూడా కొంత హెల్ప్ చేసిన వాళ్ళు అవుతారు మీ సైడ్ నుంచి. సో కాబట్టి నా ఛానల్ని ప్రమోట్ చేసి నాకు కూడా హెల్ప్ చేసిన వాళ్ళు అవుతారు. వై? బికాస్ సో యు ఆర్ సపోర్టింగ్ మీ ఎ లాట్. సో వి క్రాస్ 250. మనం 250 క్రాస్ అయినాం బికాస్ ఆఫ్ యువర్ సపోర్ట్ ఓన్లీ. హియర్ టుడే ఐఎమ్ మేకింగ్ సమ్ వీడియోస్. సో కాబట్టి మీ అందరినీ కూడా నేను ఒకటే రిక్వెస్ట్ ఏం చేస్తున్నానంటే, keep on watching the videos. And one more request from my side, complete up to the end you see the video. Why? Because you know very well, so that's very useful videos. సో కాబట్టి చివరి వరకు కూడా చూడడానికి ప్రయత్నం చేయండి. ఈ వీడియోలు మీకు ఎంతగానో ఉపయోగపడతాయి. అదేవిధంగా నా ఛానల్ని ప్రమోట్ చేయమని చెప్పేసి మీ అందరినీ కూడా నేను రిక్వెస్ట్ చేస్తున్నాను. ప్లీజ్ కీప్ ఆన్ వాచింగ్. Like, share, comment and subscribe. Don't forget to bell.